Welcome to aminacademy.com. In material science and engineering, let us discuss about atomic bonding in solids. An understanding of many of the physical properties of material is predicted on the knowledge of the interatomic forces that bind the atomic together. Perhaps the principles of atoms bonding are best illustrated by considering the interaction between two isolated atoms as they are brought into close proximity from an infinite separations. The properties of solids can usually be predicted from the valence and bonding preferences of its constituent atoms. Four main bonding types are discussed here, that is ionic, covalent, metallic, and molecular. Hydrogen bonded solids such as ice make up another category that is important in a few crystals. Now, let us discuss about bonding forces and energies. Bonding forces are forces of attraction that holds atoms or ions together to form a molecules or substances. The amount of energy produced when bonds are formed from isolated atoms or the amount of energy needed to break bonds between atoms in molecules is called bond energy. Bond energy is also known as bond dissociation energy. Next one, primary interatomic bonds. The three main types of primary interatomic bonds are ionic, covalent, and metallic bonds. What is ionic bonds in short? Ionic bonds forms when one atom donates an electron to another. Excess electron is donated to another atom, resulting in a stable number of electrons in the outermost shell of each atom. Ionic bonds can exist between alkalis, alkaline, earth metals, oxygen, and halogens. Covalent bond. Covalent bonds form when electrons are shared between two nuclei. Covalent bonds are the most important interatomic bonds in organic chemistry and polymers. Next is metallic bonds form when electrons are shared between a lattice of positively charged ions. Metallic bonds are responsible for the conductivity, malleability, and ductility of metals. Now we'll come detail about ionic bonding. Ionic bonding is perhaps the easiest to describe and visualize. It is always found in compounds that are composed of both metallic and non-metallic elements. Elements that are situated at the horizontal extremities of the periodic table. An atom of metallic elements easily give up their valence electrons to the non-metallic atoms. In the process, all the atoms acquire stable or inert gas configuration and in addition an electrical charge. That is, they become ions. Sodium chloride, for example, sodium chloride, that is NaCl, is the classic ionic material. A sodium atom can assume the electron structure of neon and a net single positive charge. By transfer of its one valence electron to a chlorine atom, after such a transfer, the chlorine ion has a net negative charges and an electron configuration identical to the organ. In sodium chloride, all the sodium and chlorine exist as ions. This type of bonding is illustrated in figures here. Further detail, ionic bond is a linkage formed from the electrostatic attraction between oppositely charged ions, that is positive and negative, in chemical compound, such as bonds forms when the valence outermost electrons of the one atom are transferred permanently to another atom. The atom that loses the electrons, it becomes positively charged because it loses one negative charge. that it becomes ion, that is cation, while the ion that gains them become a negatively charged ion, that is anion. A brief treatment of ionic bonds follows. For full treatment, we can see further. Here, look at here, sodium ion becomes positively charged when loses one electron, and the chlorine ions gets negatively charged one electron it attracts. So it becomes positive charged ion, this becomes negative charged ion, then both attraction, it bond formed. Ionic bond resulting in compound known as ionic or electrovalent compounds, which are best example by the compounds formed between nonmetals and the alkali and alkaline earth metals. In ionic crystalline solids of this kind, the electrostatic forces of attraction between opposite charges and repulsion between similar charges orient the ion in such a manner that every positive ions becomes surrounded by a negative ions and vice versa. Next one, covalent bonding. In covalent bonding, stable electron configuration are assumed by the sharing of electron between adjacent atoms. Two atoms that are covalently bonded will each contribute at least one electrons in the bond, and the shared electrons may be considered to belong to both atoms. Covalent bonding is schematically illustrated for CH4 methane molecule. Here, covalent bond, the interatomic linkage that results from the sharing of electron pair between two atoms. The binding arises from the electrostatic attraction of the nuclei for the same electrons. A covalent bond forms when the bonded atoms have a lower total energy than that of widely separated atoms. A brief next one. Molecules that have covalent linkage include the inorganic substances for hydrogen, nitrogen, chlorine, water, and ammonia, together with all organic compounds. In structural representation of molecules, covalent bonds are indicated by solid lines and connected pairs of atoms. Look at here, a hydrogen have one electron in outer shell, and chlorine have needed one electron. So hydrogen have excess electron, chlorine needed one electron. So both together sharing the electron. Like if I here one hydrogen electron from hydrogen atom and one electron from chlorine atom together combine and forms hydrogen chloride. In methane also, here in carbon, four electrons in outermost shell, and one hydrogen have one atom in outermost shell. So like four hydrogen atom combined together, one chlorine atom forms a metallic bond, covalent bond. This a single line indicated bond between two atoms involving one electron pair. Double line means double pair, double bonded. Triple means triple electron pair. Suppose here, for example, carbon monoxide have triple pair of sharing. Covalent bonds are directional, meaning that the atoms so bonded prefer specific orientation relative to one another. This in turn gives molecule definite shapes, as in angular bend structure for water molecules. Like when none of the element in a compound is a metal, no atoms in the compound have an ionization energy low enough for electrons loose to be likely. Next, we'll discuss about metallic bonding. Metallic bonding, the final primary bonding type, is found in metal and their alloys. A relatively simple model has been proposed that very nearly approximates the bonding schemes. Metallic materials have one, two, or at most three valence electrons. With this model, these valence electrons are not found to any particular atom in the solid that are more or less free to drift throughout the entire metal. They may, they may be brought of as belonging to the metal as a whole. This forming is called sea of electrons or clouds of electron. Here, look at here. A metallic bond, force that holds atoms together in metallic substances such as solid, consists of closely packed atoms. In most cases, the outermost electron shell of each of the metal atoms overlaps with a large number of neighboring atoms. As a consequence, the valence electrons continually move from one atom to another and are not associated with any specific pair of atoms. In short, valence electrons in metal, unlike these in covalently bonded substances, are non-localized, capable of wandering relatively free throughout the entire crystal. Here, this is the metallic bond structure, simple structure. Metallic bond forces that holds atoms together in a metallic substances such as solid consist of closely packed atoms. In most cases, the outermost electron shell of each of a metal atoms overlaps with a large number of neighboring atoms. As a consequence, the valence electrons continually move from one atom to another and are not associated with any specific pair of atoms. Many of the characteristics properties of metal are attributable to the non-localized or free electron character of the valence electrons. Many of the characteristics properties of metals are attributable to the non-localized or free electron character of the valence electron. Some general behavior of the various metallic types, that is metals, ceramics, polymers, may be explained by bonding type. For example, metals are good conductors of both electricity and heat. As a consequence of their free electrons, by way of contrast, ionically and covalently bonded materials are typically electrical and thermal insulators due to the absence of large number of free electrons. So far we discussed about metallic bond and bonding energy. We'll discuss further in future videos. We have done. Please subscribe our YouTube channel.